So I've just sent out the practice exam. Again, your first exam will be held in lab on either the 21st or the 24th, depending on when you're having lab, right? You need to go to your lab for your exam, right? You can't just show up to the Monday lab because you like the idea of having those 2 extra days. It's not necessarily as much of an advantage because I plan on going over the practice exam on Thursday. So that would be helping you study the day right before the exam, right? So I'm going to go over all the answers for the practice exam on Thursday. So as I mentioned, you are allowed 1 sheet of paper, front and back, as long as that sheet does not basically interfere with anyone else taking their exam. Can be handwritten or typed. I don't care. The exam does take up. The allotted time for the exam is the entire length of the lab, but I don't think you would necessarily need that. Some students do, but the bulk of the students don't. But that time is there because I found, at least for me, when I was much younger, the anxiety of just, oh my gosh, am I running out of time, was just the worst for me when I was taking exams. On a similar note, students who need to take their exam through alternate proctoring conditions should reach out to me should reach out to DRS to schedule their exams, right? Reaching out to DRS, they handle exam scheduling and the like. As long as your schedule, I prefer to have it on the same day, but as long as it's within, a week of your signed of that initial Friday, that's great. So again, the exam, the last possible, don't schedule past the end of the month, please, though. Spring, once we hit spring break, this exam is basically closed to everybody because I can't proctor that. That's too much of a long distance. Again, if you're sick, right, don't come to the exam. Just let us know and we'll figure out a way to make it up. And worst case scenario, I will just simply give you a 0 on that exam, and you'll just have to make sure you do well on the other 2 exams because we'll do best 2 out of 3. We will drop your lowest exam grade. We'll have 3 exams plus the final. Of those 3 exams, not the final, we will drop your lowest exam grade. I just want to be clear that the exams are different than the final exam. They belong to different grade categories. Okay. So, sorry to sound all angry about that or something like that, or stern or whatever. The point being is that I just have to say that verbiage simply because every so often I get deliberate misinterpretation from students who missed the exam from one reason or another, or creative interpretation, shall we say. So I try to be very specific. I prefer honesty. If you overslept the exam, just tell me and I might laugh and I might be nice because I've done that. Just be open with me, please. You should know I'm not a jerk. I just don't like it when I'm lied to. That's all. So it's also just really funny. So, oh well, it happens. And again, worst case scenario, the exam 3 is going to be there for the purposes of making up. Exam 3 is not optional, right? Unless you want that 0 and you're good with the other 2 grades, right? Does that make sense? None of these exams are optional unless you're okay with banking everything on 2 exams, right? Technically, everything in this class is optional if you're okay with getting 0s for it. You get what I'm saying? So, all right. So with enough of that nonsense, let's go get to the fun stuff because I need this distraction. Today we go over I used to do these exams online. This is not indicative of anything. So during COVID specifically, they were done online. Occasionally I'll do something similar for a student who's needs to be proctored remotely for very extenuating circumstances, but that's very rare. Today we're going to learn about time. right? We all know about time, but specifically we're going to be learning about, we're going to be doing this exercise under Module 5, the in-class exercise called Blame Pope Gregory the 13th. That name is, of course, in jest if you are a big fan of Pope Gregory the 13th. So, this is from Savage's textbook. It was originally a Java program, and I've adopted it. And what it is that what it gets down to is that it's very important for humans to track time. Initially, tracking the seasons is just really important for agricultural reasons, figuring out how much time you have to grow crops and harvest them so you can plan for having enough food during the winter, as well as figuring out how much light there is in the day for daily tasks. There's a lot of actual formal names for different periods of night, like dusk and evening and night are distinct things that astronomers have names for. What we're specifically dealing with is dates, specifically the phenomena of leap years. So most of you have been incorrectly taught what a leap year is, but that's fine because it's actually right the vast majority of the time. This rule the rule that you've been taught incorrectly is actually fine, perfectly fine and serviceable the vast majority of the time. And again, we're just with the way the Gregorian calendar works, which is why we're blaming Pope Gregory the 13th. It's named after this guy. Is fairly straightforward. On years that we call leap years, we add an extra day to the calendar. We add that day in February. And that day is February 29th. That only occurs on leap years. Note that I did not say every 4 years. I said days that occur on leap years. Leap years don't occur every 4 years. That's the incorrect rule, believe it or not. And this actually isn't necessarily as complicated as some other. Every calendar has to adjust for basically the fact that the rotation of the Earth and the revolution of the Earth around the sun does not cleanly line up. For instance, the Jewish calendar, and I'm not sure about the Islamic calendar, but I believe it's the case. Those are lunisolar calendars, meaning that they occasionally add, I know the Jewish calendar adds leap months. Anyway, is that true for the Islamic calendar as well? A leap month? No one wants to venture that? Let's see. But that's a whole thing, a leap month. Could you imagine adding an entire month to the year? In many cultures that combine monthly cycles with the solar year. That's when basically your month is defined by by full moons, essentially like that, and new moons. So let's see: Chinese, Buddhist, Burmese, Assyrian, Hebrew, Jain, Kurdish, Welsh, traditional, Pali, Hindu, Japanese, Korean. Ancient pre-Islamic calendars. Okay, so I'm not sure about that. So there are a lot of okay, but in contrast to purely lunar calendars such as the Islamic calendars, they have intercalculation rules that rough agreement with the solar year. So yes, it is suddenly it gets a lot more complicated. Suddenly this timekeeping business is a lot more difficult than we thought it was, right? So what it comes down to is that so an astronaut, let's go ahead and look it up. Astronomical year, right? A year, astronomical year month. So let's see. They used to have it just straight on here. That was extremely useful. Astronomical month. That's a lunar month, right? Here we go. Year. Revised it, calendar. See, astronomical month. Really, you're being really annoying here, Wikipedia. You could have. The mean tropical year is 365 days, 5 hours, 48 minutes, and 45 seconds. Or approximately a year which is the amount of time it takes for the sun for the Earth to circle the sun and come back to the same point, is 365.242 days, let's call it. Got it? Right? It is not exactly lined up. It would be great if it lined up in that whole integer, because then the seasons would always occur at the same time. But because we have this extra quarter of a day here, essentially of an extra quarter of a day that it continually gets added, as such, the calendar and the seasons that we experience will get out of line with each other. Does that make sense to everybody? Eventually, you're just simply adding additional time, and that eventually pushes things back. Now, the way that this used to work was with the Julian calendar, named, so let's see, Julian year, exactly 365.2 days. From the Julian calendar, it uses a leap, and this is the rule that you're familiar with. Every 4 years is a leap year, which you add an additional day to the calendar. Named after Julius Caesar, right? And you'll notice that, let's see, today would be January 31st in the Julian calendar. Current day is February 13th. In fact, this drift of days between these two calendars was notable when this transition took place. So George Washington, born February 22nd, 1732, to December 14th, 1799. And note there's a footnote on his day of birth. I mean, you'd figure the first president of the United States, you'd be able to know pretty darn well when he was born, right? And yes, we do, but you'll see that contemporaneous records use the old-style Julian calendar and Annunciation style of enumerating years, recording his date of birth as February 11th. So here's what happens, right? Notice that I mentioned that a Julian calendar has basically is 365.25 days. It is a leap year every 4 years without exception. However, that still caused a bit of a drift. We were still getting a bit of drift there because that doesn't line up with 365.24, and over the course of a couple thousand years, the seasons have started to drift. So, this was noticed, and Pope Gregory the 13th, right, if we go back to our thing, right, commissioned and instituted the Gregorian calendar. That he was Pope from 1572 to 1585. That's not when he was born and died. That'd be really weird for a pope to be that young, you know? It's not how the papacy works. Pope Gregory the 13th, Pope from 1572, he commissioned this calendar and then implemented it. And that's what's kind of spread. It has become the most widely used civil calendar. I think every country at this point uses it. It is the calendar that you use in the United States. Some countries, I think like Russia and the like, did resist using it until the 1900s, but honestly, just everybody being on the same page is fine. If you're a member of a religion that has a separate calendar, you'll know that basically you still use your own calendars for religious dates anyway. So it's just one of those things. So anyway, the entire point of this was to add in the leap years only such increments that it would make it much closer to the 365.24 days. All right, I know that was a long introduction. This is just so fascinating to me, I know, and I'm probably like the only one this is fascinating for. All right, so let's get into the years. So let's go into the way this works. Our program today is to basically given a date, test if it's a valid date within the Gregorian calendar. We are going to use the honestly god-awful U.S. format. The U.S., for some reason, uses month / day / year. So we use the big number, the middle number, and then the smallest time unit. It's medium unit, small unit, large unit, as opposed to something like year, month, day, or day, month, year. But that's what we use, okay. So we're going to be using that because that's what the vast majority of the class has used and never really thought too hard about why that is. And the answer is just because. Valid months range from the digit from 1 to 12, right? So there is no 0th month, there is no Blemuary, or there is no Septober. So there are none of those made-up months. September, April, June, November each have 30 days, right? Remember that rhyme? All the other months but February will have 31 days. Got it? February has 28 days except on a leap year. On a leap year, February will have 29 days. So what is a leap year? A leap year is leap years, any year that is not divisible by 4, that is not a leap year, right? This is not a leap year. We don't have to add any additional rules for mental heuristics over here. If it's not divisible by 4, it's not a leap year. A year divisible by 4 is a leap year, and that is the Julian calendar rule. The Gregorian calendar added the following rules. Except a year divisible by 100 is not a leap year, except if it's divisible by 400. So every 100th year is not a leap year, except the 400th year. And suddenly you realize, oh, this is why we haven't had to really care about this, because because the next time the every 4 years rule will be wrong is 2100. It was right during 2000. So let's go ahead and look at this. 1644 is a leap year. 1645, not a leap year. 1644 is just divisible by 4. It's not divisible by any of the hundreds, so we don't have to worry about it. Okay. 1600 is a leap year because it's divisible by it's a number divisible by 100 and 400. Specifically, it's a year divisible by 400. That's what really matters. 1700 is not a leap year because, yes, it's divisible by 4 and divisible by 100. It's divisible by 4, but it's divisible by 100. And it's not divisible by 400, so it's not a leap year. So, yes.
So, was Jesus born in a leap year?
Technically, I guess he would be, but also that depends on if we're talking about religious date versus historical kind of. You're suddenly getting into the historical versus biblical kind of history kind of thing, which are two different schools of thought.
But all of those years are after that.
And of course, and if you're also a member of the Orthodox, if you're a member of any of the Christian Orthodox religions, as opposed to or I should say denominations or branches of Christianity, as opposed to the Catholic branches of Christianity or Protestant branches of Christianity, or none of those. There's a lot of different types of Christianity, is the point. Look, the Orthodox churches do use the Julian calendars for the religious numberings, right? So that would still be a leap year, but that's not even having to ask a question because it'd be every 4 years is a leap year. Make sense? Yeah. So suddenly that gets in. Yeah. No, it's the Julian calendar is still used by the Orthodox branches. Anyway. So let's see. Going back to this. So again, 2000 followed the whole divisible by 400 rules. So it was super easy for everybody to just simply teach every 4 years because you don't have to worry about it until the year 2100. And hopefully you'll be able to get to that nice year and basically be able to correct all the young people about being wrong, whether about it's a leap year or not. Okay. Now, this program, which is very simple, just simply checking if a date is a valid Gregorian calendar date. I love this one because if it looks hard and complicated to determine if something is a leap year, guess what? It's pretty much just as complicated for a novice programmer as it is for somebody who's been programming for quite a number of years, to be honest. It is one of those things that does not care too much how much you've been programming. It is annoyingly difficult. So we're going to do what all good students do when it comes to solving this problem and figuring out and getting our program working, which is that we're going to procrastinate on the hard stuff. We're going to address all the easy stuff first before we address the whole leap year issue. Make sense? Okay. So because let's go ahead and look through so first, what's the flow of this program? Write a program that, given a string as an input, tests if the given string is a valid date in the Gregorian calendar. So let's go ahead and just program that first part. Given a string, right? We're going to take in a string. So we were given a date, and we're going to take it in as an input, right? enter a date. That part is easy. Okay? Enter a date, and then we got to test whether, and then once we get that, we need to start test, we'll test for it. So let's go over here, documents, GitHub, classroom, intro, blame Pope. Okay. And so now you know why it's called Blame Pope Gregory the 13th. Don't blame me, blame him. So he's the one responsible for this calendar. So let's see. Date is equal to input, enter a date, and so that part is fairly straightforward. Now at this point, what we need to do is that we need to, as part of this program, do what? We have to test the month, day, and year respectively. And if we think about it, just kind of, and if we would spend a couple minutes thinking about it, which we're not going to, I'm just going to tell us outright. If we spend some moments thinking about it, the first step of what we want to do is test that month. Why? Because the month is easy to test. Test whether or not it's a valid month, and we need to know what month it is to detect how many days we should have, right? And then the year, we only care about the year if it's a leap year or not, because basically anything that the user enters as a year is going to be valid so long as it's a number. And we're just going to assume that the user is going to be nice and not trying to crash a program by entering the April 1st of the year Apple. So, So what does that mean we need to do? That means we need to break apart this string. We need to split it up in some way. We need to break it up into its component parts. So I'm going to help set you up, and I'm going to give you a moment to do this. So we're going to have the month. I'm going to have the day, the month, and the year, or the month, the day, and the year. It doesn't matter what order you do it in, but I want to do day, month, year, but because it's a U.S. date, we're going to break it up like this because that's the order in which you're going to digest things. Month, day, year is equal to question, right, over here. Right, obviously you don't want question marks in your code. This is me pedagogically saying fill in the blank, please. Right? And you can assume, and here's the thing, you can assume that your input string is going to look like this. Month, / day, / you can assume that the user is following the directions. Okay? And I'll leave this over here, but first let's go to the PDF, right? These PDFs, there's a reason, this used to be a homework, so what we're going to learn today is a nice strategy called slicing, where you can get a subsection of a string, right? We need to basically take apart this string, right? The string has different parts. We want to split it up, right? We want to isolate the month, the day, and the year. Make sense to everybody? We need those individual parts. The way we can do that is by a technique called slicing. A slice gets you a substring, as it's called in Java. It gets you a small subsection of the string. The format is index to end in the same way that a range function has the start point and the stop point, right? The range has start at this index, go up to, but not include this number, right? That's the way the range function works. Same way that a slice works. It says start at this index, go up to, but not include this index. So let's go ahead and assume that I've got a string called my name. The slice from 0 to 2 gets index 0, index 1, and does not include the space. Make sense? Technically, this should be a capital M. Great job. Great job, me from the past, because you messed that one up. All right. String from index 3 to number 6, that gives us nam, right? Index 3 over here. In fact, let's go ahead and grab these. I'm going to grab these and put these into the PDF because I'm going to do what I'm going to do for you over here, which is I'm going to just simply put a comment over here, right? And this is especially useful, I find, when you're just starting out, or if you've got a long string and you're not just starting out. which is to label your indexes, right? You can totally do that. Why make work harder for you? So index 3 to 6, 3 up to but not including 6 gives us now. So interestingly enough, if you leave off the endpoint, it's gonna do the least surprising thing, which is saying, oh, you want 3 until what? I guess I'll just go to the end of the string. Yes?
For S2, would 2 not include the space? Or-
No, it would, index 2 would be a space, but 0 to 2, it goes up to but does not include the space. So just like a range from 0 to 10 goes up to but does not include 10,
Okay.
right? So here, this one goes up to, 3 to 6 goes up to but does not include index 6, which is E. Make sense? So over here, string 5, this is not a slice. If this is a normal get something at an index, right? If it does, the way you know it's a slice is if it has a colon in it. Make sense? Over here, index 2 to 3, right, goes up to, starts at 2, goes up to, but does not include 3. You can have a slice just one long. I'm not sure why, but you can. Yes?
What's the difference between a slice and just character?
And just getting a character, you're getting a subsection rather than one. You're getting, the difference is whether you want to grab one thing out or you want to grab a contiguous space, like a contiguous slice of it, right? You want to get, it's the difference between grabbing one thing from it at a time or grabbing a whole group of them all at once.
But if the width of your slice is just one character,
Why?
it would be
Because just because you can doesn't mean you should, right? It's one of those cases where basically it feels silly to give an error for just trying to get one and tell the user they should just get a space. It's also sometimes very useful because slices do not have this nifty rule where if you try to do a slice, it will not go out of bounds, as I'll demonstrate later. So over here, let's go ahead and try to, I'll give you the chance to slice out the month, the day, and the year. We'll do this, and I'll help you by doing this for you, where I'm gonna just label those indexes for you. So go ahead and take a few minutes to basically get those slices. It'll look something like this, date, and then you need to slice from those locations, right? Right, so replace start and end. Make sense to everybody? So just take a minute to do that, right? Slices are a super duper useful feature of Python that is not necessarily present in other languages, although other languages do have functions that imitate slices. The month starts at index 0. So some companies that companies like C, they care about the way in which you talk. Python does not care. Will define is the way it works that you register the function and then kind of look at the go ahead and do this. Let's go ahead and do this. I'm going to go ahead and add, so I'm going to go ahead and comment out this nonsense because we don't need it. And really, again, by commenting this out, I'm turning that into a multi-line string, and it's just kind of sitting there, existing, and the computer's doing nothing with it. So what I'm going to do here is I'm going to get those, and I'm going to print those out. Print month, comma, day, comma, year, just to say, am I getting the right thing? Right? So I've got my start to end. So for month, that's going to start at 0, go up to, but not include the slash, which is index 2. 0 to 2. For the day, that starts at index 3, goes up to, but does not include index 5. Right? This is why I said, like, putting down these numbers makes everything easier. It does. You don't really, you can kind of just visually look. The main thing is to remember it works the same way as the range definition, which is you go up to, but do not include that number. So index 3, up to, but not including 5. And again, how do you know if this is correct? You have to test it. Finally, this one's a bit tricky, I feel, or there's some uncertainty, and you just kind of have to have some faith here, which is that, okay, it's going to start at index 6, and it's going to go up to and not include what now? Well, you can do this, as I showed earlier. You can also go up to, well, it would go up to and wouldn't include index 10, which is good because that doesn't exist, right? That's another way to do it. And so we can run this and enter a date 01 slash 24 slash 1999. It does that. I'm going to go ahead and for testing purposes, and I do this all the time when I'm doing input functions, I'm just going to go ahead and hard code this in so I can run it multiple times very quickly. Let's do it. It doesn't matter what the year is right here. 1/24/2024. Run it, and that's fine. Note that if we leave this off, right, it will go from 6 up to and include the end. But here's a fun thing about slices that's a really interesting quirk of Python, and I'm not really sure why it happens, but it does. You can't really go out of bounds when it comes to slices. I feel like that's enough zeros for emphasis. It just goes up to and doesn't include the end. There's not a bunch of like spaces after it or anything like that. It just doesn't include that. So it's a good way to avoid dealing with something that might get you out of bounds. The only other thing worth mentioning that we can quote unquote simplify this with, and it's your and definitely personal preference as to whether you find this simplified or not, is you can remove the start point, and if you leave off the end point, right, what does that do? That goes all the way that goes all the way to the end. If you leave off the start point, it's the same thing as doing it starting from 0. Make sense? Incidentally, if you do a slice like this, you're just simply creating a copy of the whole thing, right? This is create a slice that goes from the beginning to the end. It's the entire thing. It's a useful kind of shorthand for doing that. We will go into some other useful things as well later on, such as this, and then my personal favorite, which is this, which is everything but the last item. Anyway, let's continue because I don't want to run out of time for this problem solving. All right, so now what we're going to do is that we are going to tackle figuring out if this is a valid month. So we've got 4 conditions here, basically, or we've got 4 groupings of months. We have 12 different months, and it doesn't make sense to, we kind of want to, I feel like the right way to structure this program is we have, we check the month and then check the day. And then if it happens to be February, if we happen to be in February and the day is the 29th, then we check it's leap year. We only check the leap year if they tell us it's February 29th. Make sense? Because that's the only day. So it doesn't make sense to check, okay, if it's January, then I want to check for hold on. You think I have that memorized? No, I do not. Right? 31 days. I don't want to memorize that. If it's September, I need to check 30 days as well. It doesn't make sense to check each month at a time. So let's group them together, right? What do I mean by that? We should check. So we should ask ourselves, is this a 30-day month? Is this a 31-day month? Sorry. If this is a 30-day month, then we can check if the day is between 1 and 30. If it's a 31-day month, we can check if it's a day between 1 and 31, right? If it's February, we can check if the day works for February, that's its own thing. And if it's not one of those three categories, then the user probably entered something that was bubkis. That was just a bunch of nonsense. Okay. Technically, I misused bubkis there, mainly because bubkis is nothing. But it was Yiddish and it sounds great. Yiddish is definitely, I don't know what the king of languages is in terms of linguistics, but Yiddish would definitely be the jester. Let's go ahead and say, so we're going to do an if statement, right? So first thing we want to do is check if it's one of these four. So let's start out, take a moment to write if these 4 months, if the declared month is one of these 4 months. And I'll just give you one big thing that we need to do beforehand because I almost forgot it even though I was thinking about it. If we're going to be checking numbers, we should probably turn these into integers, right? So just remember to turn these all into integers. And now over here you want to check. Yes, that's fine. And now over here, check if and that is check if 30-day, right? Make sense? So write an if statement that checks if it's one of these things. You don't have to put anything inside of it. Just simply write the statement itself, then we'll continue. This is going to be a compound Boolean statement if it's one of these things, or if it's one of these things, or if it's one of these things. All right, so let's continue with this. So what we want to do is check, hey, if it's September, April, June, or November, right? So how do we write if it's one of these things? We're going to write if the month is equal to those numerical values. So if month is so for September, let's just go ahead and do that order. That is 9 for April, or month equals 4, or month equals June, or month equals November, which is 11. Right? Annoying, I'm sure, for the non-English speakers or non-native English speakers, I should say. So that would check one of the four things. Once again, the common mistake that you'll make at this time is basically doing something like if month equals 9 or 4, right? Or, and then, yes.
Would it not be 09, 04, and 06 since it's based off of the...
Excellent question. So the answer is that it was that way when we had it as a string, but I just turned these all into ints. That is an excellent question. So when we turn these into, it's when you take a string like this. So first off, if I just simply put in a bunch of preceding zeros, if there's a bunch, it will have error. In fact, actually, it will error out this interesting. Sometimes other languages, I don't think it use interesting. I think in Java it lets you do that, but that's why I'm surprised here. Yes, it's saying it wants it to use it says use 0, O if you want to do octal, which is saying if you want to work in base 8, which would be basically like doing this. 0, O, and 10, and 1, 0, that would be 8. That's octal, where the valid digits are 0 up to and including 7. 8 valid digits. So that's useful when you're working with binary nonsense. Anyway, so you wouldn't necessarily do that. If you did not convert them into strings, however, if you did not convert them from strings into integers, then you definitely want to do this. Make sense? Okay. So now what I'm going to do over here is I want to finish out the rest of the conditions. So I'm going to put it down pass. Think of pass like to do. Okay? You never really want to see it in your code. It's just simply saying where to come back to this. Why? Because I want to write the other conditions here. What we're going to do over here is an elif, which is short for else if, meaning that this is when you have multiple if statements, but you only want one, but it's only possible for it to be one thing. Make sense? Else if. It's not going to. If statements can imply, if you have multiple if statements and they don't have an else, they imply that multiple of these things can be true. Now, mind you, if you just did ifs, it would be fine, but it's good practice when you mean something not to imply it. So here we would handle elif. So what we're going to do over here is 31 months. If Feb, we're going to do February there. And then what we'll do over here, right? And all I'm going to do is if blank over here, and we'll put in, again, passes just as a to-do so we can fill them out. Because the indents need to have something inside of them, and the pass works like that to be able to put in a to-do. And then finally, this part I'll do over here where we have an else. The else over here says, well, if it wasn't one of these categories, then you probably gave me one of those made-up months like Blembuary or something like that.
Or
Tricember, sure. We're going to go ahead and we are going to simply print month and then is an invalid? This isn't Final Fantasy 11 or 12 rather. invalid month. Technically, that would be tactics. All right. And if we run this now, right, invalid syntax. Oh, right, because I put in question marks. So I'll just simply do false over here, right? Replace those falses with whatever. But I can just demonstrate to you right now that it gives me 1 is an invalid month because we don't catch it, right? Whereas if I put in, let's say, the 50th month, it'll tell me 50 is an invalid month. Make sense? Once we put in the other conditions, it will catch it. So go ahead and put in those other conditions. That should take you just a couple minutes, and then we're going to tackle each one of these months individually. Also, interestingly enough, if you haven't figured this out, this program will involve a grand total of 0 loops. This is, I like this one because it's difficult or annoying. Again, and it doesn't involve having to do any loops. It's a very straightforward kind of question, but doesn't mean the answer is straightforward. Yes. So basically, so this, and then it's going to check the next one, and then the next category. So here you would do check if month was 1, or 3, or see else if it's between if and else it go over the videos, but like if I'm writing a program to try and tell you what's in the grade done, and I write my program like this, if the score is 90, print out A, if the score is 90, 80 or above, print out B, if the score is 70 or above, print out C. And I print enter that the score is not a 92, you would not print out A, you would print out A to C. Because ifs would all fine. Because the program's very literal. Oh, if it's greater than 90, yes it is. If it's greater than 80, okay, it's also greater than 80, yes it is. So the else if prevents says as soon as I find one of these conditions that is true, that is the one we're going with and the only one we're going with. Check is check pass it all pass does is like a film is I'm coming back to this and erasing it and filling it.
So else it is
No.
message.
Yeah, else is the part that matters. So the if and else if really the else ifs are just basically saying if only one of we are explicitly saying only one of these possible things can be true. And the else without an if serves as a default value. Make sense?
What for
those will be checked in the passes will do next. What we're going to do is we're going to fill in like checking for each day. No, we're going to replace the false. And just put in falses so that it would run. Okay. So I'll go ahead and fill this out just to make sure that we still have plenty of times for the next part of class. Oh, want Clipchamp. Okay. Okay, so we're going to replace the false with all the other months. So we just kind of go with process of elimination. If month equals 1, or month February, it's its own thing. So what about 3? That's not in there. So March is in there. Or month is equal 4. 4 is up there, is already in the category above. Month is equal to 5. So May has 5. May has 31. June has 30. July has 31. Let's go ahead and start. This is getting annoying. Let's copy paste. Or month is equal to 8. There we go. Now I can copy paste properly. But it's not that it matters that much at this point. Or we've got 9, October, and then 12. Let's just do a sanity check. 1, February. Okay, let's do February over here. Month. This only needs one condition. If month is equal to 2, right? If it's that's all it needs. So if 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 12. Yep, I did indeed go to first grade. So got all those numbers down, Pat. So now what we got to do is we're going to fill out these things one by one. Okay? So what we're going to do over here is now we've determined whether or not a month is valid, and when it is valid, we've kind of categorized them. So we know if we're in this if statement, that means the day that there are 30 possible months, so not 30 possible months, 30 possible days that are good, right? The days 1 to 30, right? And we can basically say, hey, if, and we'll put in a clause here, our Boolean clause, print. So if it's we'll say invalid, if valid day, whatever that is, we'll print out that it was a valid day. Else, print day, we'll say day is not valid, is not valid for, comma here. It's reflex to put the comma inside the quote mark, because that's, when you're writing English, that's what you do. So, is not valid for month, and then close this parentheses. So basically what we're doing here is saying, hey, and so what are we checking with this if statement? This if clause over here is basically going to be saying to us, hey, is this in between the range of 1 to 30? And there's like a ton of ways to do this. 1 to 30 inclusively, by the way. If so, great, awesome. The day is, the month is fine, the day is fine, and the year is whatever it is, because the number for the year doesn't matter, it's just a number, right? And then we can do the same thing for the 31st. Great. So, go ahead and figure out what we should be putting here in place of this text. And the tools, again, that you probably will need to use is that we've been checking for equality. But listing out all 30 values sounds like a real pain. So, make use of those skills you learned in elementary and middle school. For the greater than signs, remember the alligators? Sure, you learned that. Anyway, you want to make use of the less than, greater than, or the less than, or the greater than or equal to, or the less than or equal to. Those are tools that you can use for Boolean expressions. You can also use and I tease. I'm not trying to be insulting with the alligator quip. I'm teasing. I'm trying to emphasize the symbols here. You know, you've learned them, and you're very familiar with them. They're just in an unfamiliar context, and that can make things scary. Yeah. If you haven't figured it out yet, I'll just be a bit clear. Right? What we're looking for is something where we compare one value to another, like checking, like, for instance, if we have a value x is 5, right? We're checking for something like this. If x is greater than or equal to 2, right? The greater than or equal to expression will return something. You can chain things together, like say, if this is true and this is true. One more minute on that. Let's keep going. All right, so we're going to finish most of this program in one fell swoop. So I'm going to show you the way that I kind of just implied to do it, and the way that most programmers who are learning Python for the first time would do it. Incidentally and interestingly enough, this is not the easy way to do it, and the non-programmers probably did it the easy way. So, or I should say, are more likely to have done it the easy way. So if it's a 30-day month, that means that the valid dates are 1 through 30. So what we want to do is check, hey, if this day value is greater than or equal to 1, right? And the day value is less than or equal to 30, right? Make sure that if it's above 30, so if it's above 1, if it's above or equal to 1, and less than or equal to 30. Also possible to do less than 31, right? Same deal there. Since we're dealing with whole numbers, those mean the exact same things, but less than or equal to 30. It's a valid day, right? This should mildly bug you, right? Because you've got this day is greater than, and then you've got the less than, and while it makes logical sense, it doesn't look quite right for some reason. Why? Because you've learned a better way to do it in mathematics. You've learned a much better way to do this in mathematics. And the way to do it in mathematics is the way you can do it in Python, and I much prefer it that way. Right? That should look right. That look fine to you? Yeah. And just to show you, I'm not fibbing on this one. 5 is less than or equal to, 5 is less than 10, which is less than 20. That's true. 5 is less than 4, which is less than 20. False, right? 4 is not, this is not true. Python is great because you can do that statement and you don't have to do the ands or the ors there. It takes care of that automatically. It's so nice. Cannot overstate how nice being able to do that is, especially when you're dealing with long ranges and stuff like that. So what we can do for this is fairly straightforward. For 31 days, this is easy, right? What do we do for 31 days? We change that 30 into a 31, right? Let's go ahead and just be clear about this month. For month. Oh, invalid. Day, yeah, I should have finished writing this. Okay, so we'll test this over here, right? 5824. If we try 1224, it's going to say that's a valid day. And then finally, if we try the 50th day of December, it will tell us 50 is not a valid day for month 12. Make sense? For February, we've actually got most of February done right here. And we'll do that right now. So for February, we know that if it's between the days 1 through 28, there's no questions there, right? No questions there. If it's between 1 and 28, then it's not we don't care whether or not it's a leap year, right? Like today, it wouldn't matter whether it's a leap year or not. It's not going to change if today's date is a valid day. The next condition is going to need to do something. And what we're going to do over here is that I'm going to make it abstract, right? Because checking the leap year is its own big thing. So we're going to do that somewhere else. It's its own special task. So this is what I'm going to write. Else if day equals 28, sorry, not 28, is days equal to 29, that means we have to check it's a leap year. And is leap year print valid day for I'll say comma year, right? Make sense? So here I've declared I am calling a function. This function does not exist. In fact, if I try to run it, actually if I run this program, it runs fine. This is the fun thing about Python. It runs fine until I try to do February. Specifically, if I try to do February, if I do February 27th, it will run fine. If I do February 29th, it's going to crash and tell me, hey, you're trying to use a function that does not exist. And this is actually going to be interesting to see, and I'll be able to explain. I'm not sure what's going to happen, but I have a prediction, but I can explain it either way. This is fun. Yep. It only cares about this. And what happened here is that it only checks this if it knows it's the 29th. And so because it was the 32nd, it checked, is it this range? No. Is it this? Well, if it's not this, I don't have to check this. It's a bit of a feature called short-circuiting. And then finally, it printed out. That was what I was thinking was going to happen. So that means, of course, that, I'm putting in something here that's completely made up. So we should probably make that thing. And that's what I'm going to do here for our last 10 minutes or so. So def is leap year. Given a year, return true or false whether it's a leap year or not. Now, how do I do this? Well, when you've got these kind of things, I like to say, we want to make an assumption, right? We're either going to assume it's a leap year and try to prove that it isn't a leap year, or we assume it's not a leap year and try to prove that it is, right? I'm just going to go ahead and assume that it's not a leap year. And now at least my program will run. It'll run incorrectly, but it'll run now. So this function, how do we go about doing this? Remember, the years that's got to be divisible by are four, the years that work for it are, if it's divisible by 4, not divisible by 100, unless it's divisible by 400. Now, instinctively, so take a moment for this, but here's the thing I want to aid you with here, because I've had the benefit of solving this problem multiple times. Instinctively, because I started saying the rules, it's a leap year if it's divisible by 4, but not by 100. Sorry, it's a year divisible by 4 unless it's divisible by 100, unless it's divisible by 400. Because of that, your first instinct is to check whether or not it's divisible by 4. That's not the optimal route to go. My hint to you, and try it for the next couple minutes, is make your first check to see if it's divisible by. Actually, we don't have time for that. I'm just going to have to go for it. So the first thing we're going to do is actually check to see, is this sucker divisible by 400? Now, it's possible to do just by doing it by checking if it's 4 and then working through the logic, but you end up working with something that looks like this. See, I have an issue sometimes where I love the sound of my voice too much. And it looks like this, and it looks horrible, right? So we're going to try to avoid that. So we're going to work in reverse, which has benefits of us being able to make assumptions about what's already true. So first thing we'll do is we'll ask ourselves if it's divisible by 400. Let's just ask, before anything else, if year divided by 400 equals 0. That means it's cleanly divisible by 400. If the year is cleanly divisible by 400, it is always a leap year, right? If it's divisible by 400, that means it's divisible by 100 as well, but we don't have to check that because it's both divisible by 4 and 100 by virtue of being divisible by 400. Okay? So if it's divisible by 400, we can just say it's a leap year. Now, here's the fun part with the else-if statements. If year is divisible by 100, we can just write that. Why can I just write that? Because of the order we're going in. Because of the order we're going in, I am simply asking, is the year divisible by 400? If this is false, I then ask, is it divisible by 100? And when I'm asking this question, I've already asked, is it divisible by 400? I can assume it's not divisible by 400. So I don't have to ask, is it a year that's 100 and not divisible by 400? I already know it's not. If it's divisible by 100, I know it's not a leap year at this point because it couldn't have been divisible by 400, right? I know it's not an exception to the rule. I already checked the exception. Make sense? I got overly passionate about that. Anyway, year. And then we can just simply check the normal rule. The rule that you already know. if it's divisible by 4. Right? If it's divisible by 4, if we're asking, because we're going in the order that was counterintuitive, right? We know if we're asking if it's divisible by 4, we've already checked if it's one of the multiple of 100. We know it's not a multiple of 100 because we've already asked that. The only way we can get here is that if it's not divisible by 100. So we can return true. Make sense to everybody? And then over here, we can say return false, and I'll remove this other return false. We don't need it anymore. And what we're saying is that if we get to this point, well, I've already checked if it's divisible by 4, and since it's not divisible by 4, or any of the previous numbers, which were also divisible by 4, it can't be a leap year, right? Surprisingly simple, right? Because the alternative is doing some madness that looks like this. If the year is divisible by 4, okay, so this is the alternative. If the year is divisible by 4, I'm just going to put that there, else return false, right? If it's not divisible by 4, we know it's not a leap year. But if it's divisible by 4, the first thing we have to do is ask ourselves if it's divisible by 100, right? But if it's not divisible but if it's divisible by 4 and not by 100, then we would do else return, then it's a leap year because it's divisible by 4 but not by 100. If it's divisible by 100, then we have to ask if the year is divisible by 400. And yes, we can bunch these up with and statements. Oh, and yes, I have to remember to put equal equals 0. Yeah, that looks totally not complicated whatsoever, right? That's the way that I normally do it if I'm going to follow the normal kind of logic. But, and again, you can group these together in and statements and it looks a lot cleaner. But sometimes by checking the conditions first in the counterintuitive order, you can do this. So, again, I'll be uploading this to GitHub, so you'll be able to copy it down. But now, whoops, deleted a little too much there. Let's go ahead and we don't want this anymore. We don't need it. We'll just simply comment it out. Okay, and so now we run this code and boom, 29th is valid for 2024 for 2300. It should say 29 is not a valid for month, let's say for month 2, let's go with month 2, year, comma, year. And now we run it again, it says it's not valid for month 2, year 2300. And then if we try 2400, which is divisible by 400, you get it. So last thing I'll note, so what you want to do is take this code that you've written, and it's fine if you didn't finish it, right? Because I'm just going to check what I do with these is I check, did you vaguely follow this lecture, right? Did you attempt to follow this lecture? I'm not looking to see if the code is complete. I'm looking, were you following along? Were you trying it? Did you write anything down? Did you participate for the level? That's what I'm looking for. If you did, full credit. And if you didn't, please fix that. So anyway, so you'll want to turn it in right over here in the Dropbox for under modules for blame Pope Gregory the 13th. The last thing I'll leave you with before I leave you is, this grading criteria does not matter. It is from when I actually gave this as homework. Is that there is a postscript here about time. Time and dates are extremely difficult things to handle on your own. Do not attempt to do so. I cannot remember if there was a vote or not to stop handling leap seconds. Yes, that is a thing that happens. Leap seconds. Okay. God help you if you're trying to figure out the whole time zone thing, because every time a new country happens, they choose a new time zone to be different than their neighbors. It happens, or not every time, it just happens a lot. Do not meddle with time. Like, both in, like, don't make time travel machines, and, like, just try not to make your own time libraries. Basically use the libraries that are provided to you by the system or by your programming library. They have been error checked and have found all the errors for those, hopefully. There's a video from Tom Scott on Computer File that explains thoroughly the whole don't mess with time, because you don't want to have to redo all that work. Time zones are complicated business, even within the US. Yeah. Seriously. Okay. Anyway, you're all good to go. Have a good parade if you're, doing that thing tomorrow. And
How are you?
otherwise, have a good weekend. Yes. Give me 1 second to close this up, and then I'm going to